about its application, how it will be measured, then losses, then there is pipe network and the Hardy cross method. Then today we will cover few topics on the hydraulics such as forces on immersed body, then how that flow will be measured out of the channel and pipe, the dimensional analysis and the basics of hydraulic machineries. Okay, so our first topic is on forces on immersed bodies. Now see, when your submerged body moves in a fluid, forces depending on its acceleration and velocity acts on its body itself. Therefore, it is very much essential to solve the equation of motion of the structure appropriately by taking these fluids into the account when analyzing for various phenomena of interaction between air and the particle. When we have to solve these types of problem, we have to consider that either one of the body is in motion and other body part is in the rest condition. For an example, if you will consider an aircraft into the air, in this case what is happening? Your aircraft or object is in motion and your air is at the rest condition. Again here two variables are there. Same with the liquid condition or for the fluid motions, when your any body or any object is in the liquid, that will be considered as your immersed body. Okay, now suppose to be that body is moving in a horizontal x direction. Okay, that x direction movement is maybe inclined with vertical y or with the horizontal x. So the axis of the moving object will not be same as the axis of the component or axis of the media through which it is actually moving. So what will happen? It's self-weight, or you can say the force, the normal force will act in a perpendicular downward direction and it will be perpendicular to the direction of motion of that object. Is it? So when you are considering an object which is flowing through the media. Okay, suppose to be you are considering this media which is flowing out of the liquid such as flowing through the fluid such as liquid. Okay, and that is inclined at an angle of theta. A normal force will act on a body, that will be Fr. Just say it as a resultant force. Okay, now this force is making an angle of theta with the motion of the object, but this object is not actually a parallel to the direction of motion. Is it? So again that will make an angle of theta with the direction of motion. Now when you have to find out the different forces on that object which is immersed in a liquid or a fluid, that normal component should be broke out into the two parts, that is the vertical component and a horizontal component. So the vertical component of that force will be termed as your lift force and the horizontal component of that force will be termed as your drag force. Now, in case of submerged body, the buoyancy plays a very vital role, and the buoyancy has been given by the Archimedes principle, which states that the force called the buoyant force that lifts upward a floating or submerged body in a fluid is equal to the weight of the fluid that will be in the volume displaced by the fluid. In other words, there is a balance between weight of the floating body and the buoyant force. The point located at the center of the gravity of the displaced fluid is called the center of buoyancy. Okay. Some application where the buoyant force is addressed is your floating bodies. In order for a submerged body to be stable, the body center of the gravity must lie below the center of buoyancy of the displaced liquid. In order for a submerged body to be in a neutral equilibrium for all the positions, the body center of the gravity and buoyancy must coincide. That is, the buoyancy force point and the location of center of gravity should be same if it will be in an equilibrium condition. No submerged condition or no drag condition. For a floating cylinder or sphere to be stable, the body center, the center of gravity must lie below the center of buoyancy. Now here we have discussed that two types of forces will act on the submerged body, and the forces are drag forces and the lift forces. That is a horizontal force and a lift force. Now what is the role of lift force? The lift force will try to lift the object above the floating medium. Either it will be air or the liquid. Is it? It will try to resist itself to resist the object to get submerged to get sink into that particular media. So we have two equations or two formulas to calculate these drag force as well as the lift force. Now the force will be the component of pressure, is it? That is, it will be the pressure force. Force will be pressure into area. So here your Ft, that is the drag force, will be calculated as CD is the drag component or coefficient of drag into A into rho u square divided by 2, and lift force will be calculated as coefficient of lift into area of that object into rho u square by 2. Now in this case, your u is the free stream velocity as we have discussed yesterday, and area is the area of, A is the area of an object. Okay, now see here, if now this is the case when your body is moving inclined to the direction of media, is it? When your object or your body is moving horizontal to this media, then what will happen in this case? Your drag force will be directly equals to your total force. Okay, your F will be equals to your Fd, that is equals to your drag force. In this case, your lift force will be 0. Okay, when this case will be applicable when your horizontal component of force is 0, that is your body is moving in a horizontal x direction. Now in this equation your CD is coefficient of drag, again it is a dimensionless. Cl is your coefficient of lift, rho is your density of fluid out of which your body is moving, either it will be air or another type of liquid or water. Then u is your relative velocity and a is the area of that object. Then what are the examples can we see? One example we have seen, that is the body into your water, that is the submerged marine. Then there can be aeroplane in the air, that there can be uh, fluid possessing the force on the blades of turbine. That is, the turbine is again one of the example of the submerged body. Now see, the drag and a lift forces a lift exert on a submerged body. Example can be system of automobiles, again aeroplane, golf balls, ships, bridges, and buildings. The importance of this subject matter is provided by the streamline, the body shape of an automobile to reduce the drag or to increase the fuel consumption rate. Drastic improvement in the mileage also. Similarly, when we will consider the aeroplane example, there will be adequate lift as well as adequate drag. Lift force and drag force are essential to find out before we will design the either submarines or we will go for the airplanes. What will happen? The drag is nothing but the opposite force. Lesser will be drag, more will be your mileage of the vehicle or the submerged body. So when we will design or when we will calculate the drag force and lift force, there must be a strategy or it is a thumb rule that your drag force must be least and your lift force should be greater with the drag force. So what by using this thumb rule, what will happen? The drag force is always in a opposite to your direction of motion. Or drag will try to lower down your velocity. So lesser will be the drag, more will be the velocity, more will be the efficiency of that particular object. So drag force should be lesser as compared with the lift force. By calculating drag force and lift force, we will try to imply these forces into the practical objects or into the practical bodies, that how much forces are acting on that immersed bodies and how much efficient is that immersed body when it will come into the actual existence or in actual working condition. Now we will move to our next topic, that is your flow measurement in channel. Okay. Now see, flow measurement can you have to measure the flow. Now flow measurement can be applicable for both the cases, that is either for closed conduits and for the open channel. So before going for flow measurement, you must know the basic difference between the open channel and the pipe network. So open channels are nothing but the channels or a passage in which your liquid flows with its upper surface exposed to the atmosphere. Whereas your pipe is a closed conduit which is used for carrying a fluid under pressure. Now here, in flow conditions are generally influenced by the slope of the channel when you will consider your open channel, and when you are going for the pipe networks, your flow will be completely fill the cross section and there is no free surface of the fluid. Is it? Again, hydraulic grade line coincide with the water surface. When you will draw the hydraulic grading line, that is the HGL and TEL for the open channel, it will coincide with the water surface. But when you will draw the HGL and TL for the pipeline, it will not coincide with the water surface. Then for open channel, the shape of the velocity profile is dependent on the channel roughness. Obviously, the shape of your channel will decide your shape of the velocity profile. But in case of pipe, the maximum velocity will occur at the center only. Yesterday we have derived an equation for the for the laminar boundary flow. In that we have seen that maximum shear will occur at the surface and the maximum velocity will occur at the center only. But in case of open channel, it is not applicable. In open channel, the shape of the velocity profile will totally depends on the channel roughness. Here again, cross section cannot be determined easily because flow depth is unknown for open channel. But in case of pipe networks, you can easily find out the channel depth as well as the cross section of that pipe network. Okay. Now, when you have to find out the accurate measurement of flow rate, it is actually essential in case of the maintaining the quality of the industrial processes. Most of the industrial control loops control the flow rates of the incoming liquid gas in order to achieve the control objectives. As a result, actual measurement of flow rate is very important. Now, to measure actually the flow rate, there are so many equipments, or you can say there are so many apparatus by means of which you can find out the actual flow rate, that is the actual discharge coming out of the channel or it is entering into the channel. So there are two types of flow meters, or you can say the measuring devices. First one is your called as a differential pressure meter or differential pressure type, which will be based on the principle of measuring the pressure drops at the inlet and the outlet. And a very basic principle which is used for calculating or for the measuring a flow rate in differential pressure type is your Bernoulli's theorem. All the equipments which will come under your differential pressure type will be based on the principle of the Bernoulli's theorem. Then there is again one more principle is based to calculate the flow of the uh, measuring devices, that will come under as your variable type measuring devices or variable type flow meters. And here there will be a rotometer. So we will see one by one. So I have already told you the differential type pressure or the differential pressure type measuring devices are totally depend on the differential pressure drop between the flow, and it is calculated by the pressure drop over an obstruction inserted into the flow. Okay, the differential pressure flow meter is based on the Bernoulli's equation where the pressure drop and the further measured signal is a function of the square of flow speed. Here I have taken an example. I have taken a section with a bearing cross section. Okay, so your first cross section is section 1, the second cross section of flow is at section 2. So when we will apply Bernoulli's equation or Bernoulli's theorem over these two variable points, what will happen? We will get two equation, that is P1 by rho g plus V1 square by 2g plus Z1 is equals to P2 by rho g plus V2 square by 2g plus Z2. Here your section is horizontal, that is datum is same for both the section. So your equation will be reduced to P1 by rho g plus V2 square plus V1 square by 2g must be equals to P2 by rho g plus V2 square by 2g. So when you will solve this equation, you will get an equation or a formula to calculate the volumetric flow rate through the channel, and it is as expressed over here. Now this is the basic formula to calculate the flow rate. But when you will use difference meter or when you will use the various measuring devices, the formula may change accordingly. Okay. So we will first of all go with the venturimeter. Now, yesterday again we have seen the venturimeter. So what is venturimeter? Now you are familiar with the venturimeter. Venturimeter is a device used to measure the rate of flow of a fluid through a pipe, and it is often fixed permanently at different section of the pipeline to know the discharge in that section or discharge there. Okay. Actually, venturimeter you can see when you will go with the open channels in your laboratory to calculate the slopes, to calculate the channel depth. In those practicals, you can see the venturimeter. It is actually placed over there. Then it consists of three parts. That is you can see into the figure, a short converging part, then a through and a diverging part. Due to the construction, there is an increase in the flow velocity and hence an increase in the kinetic energy. In the venturimeter, the fluid is accelerated through a converging cone of the angle 15 to 20 degree. Okay, the angle between the converging and throat part is 15 to 20 degree, and the pressure difference between the upstream side and the cone and the throat is measured and provided the signal for the rate of flow. Now, the section which will be considered at the left side of this figure will be considered as your upstream side, and will on the right side of this venturimeter will be considered as your downstream flow. Okay, and in between there is a venturi throat, or you can say it as a throat part. The fluid shows down in cone with a smaller angle of 5 to 7 degrees, where most of the kinetic energy is converted back to the pressure energy. Because of the cone, the gradual reduction in the area, the flow area is minimum at the throat. Okay. Now again, the basic principle on which this venturimeter works is your It works on the principle of Bernoulli's equation, or it works on the Bernoulli's principle. From Bernoulli's principle, the increase in kinetic energy gives rise to a reduction in pressure. Okay, as energy will increase, pressure will reduce, both are inversely proportional. Energy is nothing but your half mv square. Okay, it is proportional to your velocity. As velocity will increase, your pressure will reduce. Okay, so energy is inversely proportional to your pressure. Okay, so rate of discharge from the construction can be calculated knowing the pressure reduction across the construction, area of cross section, then density of fluid and coefficient of discharge. Coefficient of discharge, again, it is the ratio of actual flow to the calculated flow. That is the Q actual and Q theoretical. It is the ratio of the Q actual and Q theoretical. It takes into the account the stream construction and the frictional effect. Again, whenever you are considering a Bernoulli's equation or using a Bernoulli's equation for the venturimeter, you have to consider the various types of losses. Now, for measuring discharge, we should know about the Bernoulli's equation. Okay. Again, in this section, apply Bernoulli's equation at any two sections. The flowing treatment is limited to the incompressible fluids only. Okay. So, the equation can be written in forms of energy at section 1 must be equals to energy at section 2. Okay. If you have to consider frictional losses, you may consider, else you can also avoid the frictional losses to derive an equation for the calculation of discharge or to find out an equation for the Q measurement. So when you will apply a Bernoulli's equation at two sections, it will be P1 by rho g plus P1 square by 2g plus Z1. It must be equals to energy at another section. Okay. Again here the pressure, the water is flowing through a constant velocity. Is it? So and pressure at section 1 and 2 is equal. So it will be reduced to V1 square by 2g and uh, plus Z1 is equals to V2 square by 2g plus Z2. Okay, so at the end you will get an equation to calculate the discharge that will be CD into A2 into constant. Okay, and that constant will vary as per the condition, that whether you are using a venturimeter or venturi tube or a orifice meter. Now, venturimeter is used when you are having a large volume of liquid and gas phase. Okay, but it is again having few demerits or disadvantages are also there for venturi tube, that it is highly expensive, it requires a considerable space, and we cannot alter the measuring pressures beyond a maximum limit or beyond a maximum velocity. Once the maximum velocity has reached to its ultimate points, you cannot measure the discharge out of that venturi tube. The next one is your orifice meter. Again, orifice meter will works on the same principle of the venturimeter, but the only difference is size and shape. Its advantages are it is cheap in cost, it is handy, it can be placed over any section in open channel or in pipe networks. But again, the demerits of the orifice meter are it cannot measure your discharge over a particular velocity. Again, the same drawback with the venturimeter. The second drawback of the orifice meter is it is a circular type disc type structure or a device. So in open channel, there is no such type of arrangement where you can place this type of devices to measure your rate of flow. We have seen this working. Then there is a flow nozzle. Flow nozzle is again working on the same principle of the Bernoulli's equation or working on the principle of Bernoulli's theorem. But here is the only difference between the venturi tube and flow nozzle is that it is a horizontal type nozzle and your venturi tube is a bent, or you can say it has a three different sections. Again, you have to place this equipment over the your running pipe network and you will get your discharge by applying the Bernoulli's theorem. Then there is one more equipment that is your pitot tube. It is a device to measure the fluid flow velocity at any point in a pipe or channel. Again, it is a simplest form of device to calculate the velocity. The velocity calculation is done by measuring the stagnation point and then applying the same again Bernoulli's theorem. Okay. Then there is a rotometer. Now rotometer, you can see the rotometer. Rotometer is having a wide portion at the bottom and the wide portion at the upper side and the tapered section at the lower side. So what will happen when when your water is coming from lower to upper side, so it will create the pressure difference at the lower and the upper side, and because of this pressure difference, there will be rise in the water out of that rotometer. At the upper side, there will be placement of a float type of structure. So once that float will get air or that get the pressure difference, it will goes up and there will be a measuring device and that will measure the pressure drop. Once you will get the pressure drop, you can calculate the discharge out of that rotometer. The next topic is a dimensionless quantity or the dimensionless numbers. Now see, dimensionless numbers, what are dimensionless numbers first of all? As name itself is suggesting, these are the numbers or the quantity or the values which are not having a dimension. So these are not having a dimension, it means there must be ratios of the same quantity, है ना? सेम क्वांटिटी को जब हम डिवाइड करेंगे तभी उसका जो है डायमेंशन लेस क्वांटिटी बन जाएगा. So again, dimensionless quantities or the numbers reduce the number of variables that describe a system, thereby reducing the total amount of experimental data required to make correlation of physical phenomena to a scalable system. In so many cases, what will happen? There are a number of variables, but we cannot find out at a glance that all variables. Okay, so by using this dimensionless quantity, we can reduce those all variables into the least number of variables that at a time or at a glance you can find out the unknown quantities at a rapid speed. Okay, so the most common dimensionless group is your in fluid mechanics is your Reynolds number. Then second dimensionless quantity is your Proud's number. Then there is a Euler's number. Then there is a Weber's number and Mach number. We will see one by one. Okay, so first one is your Reynolds number. Reynolds number is the ratio of inertial force to the viscous force. Simply, it is a Fi to Fp, that is a ratio of inertial force to a viscous force. Inertial force can be calculated as rho Av square and viscous force can be calculated as viscosity into velocity by length into area. So Reynolds number can be calculated as rho Vd by mu or Vd by mu. Then your second dimensionless quantity is your Proud's number. Proud's number is again a ratio of inertial force to a gravity force. Okay, so Proud's number can be calculated as V by square root of GD or V by square root of LD. When you are applying this Proud's number for pipe system, your length will be considered as the diameter of that section in pipe sections. Whenever you are working with the open channels, then you have to consider the length. In Proud's number, again, Proud's number is very important number when you have to design dams, sections, bridges, then barrages. When your Proud's number is equals to 1, it is your critical section. When it is less than 1, it is your subcritical section. And when it is exceeding the value 1, then it is your supercritical section. Then third dimensionless quantity is your Euler's number. Euler's number is a ratio of inertial force to pressure force. See, all the dimensionless quantities are the ratios of inertial force to some another force. Okay, inertial force is a constant term. So So it is a ratio of inertial force to a pressure force. Okay, inertial force to pressure force, it can be calculated as by V by square root of P by density. Next is your Weber's number. It is again defined as square root of inertial force to a surface tension. It can be calculated as by Weber's number, that is V, velocity, to the square root of surface tension into density into length. Then there is a Mach number. Again, Mach number is a number which can be calculated as square root of ratio of inertial force to the elastic force. It can be calculated by using a formula V divided by elastic stress into the density. Then there is, so these are the 5 types of dimensionless quantities. Now, dimensionless quantities are used to reduce the all unknown quantities. Is it? To once your unknown quantities are being reduced, you can find out or you can calculate your experimental data on a precise manner. Otherwise, if there are n number of unknown quantities, so you have to perform n numbers of experiment. Okay. Then there is one concept that is prototype and model. Now, model ये word सभी ने सुना है. Okay. So model is nothing but a small scale replica of the actual structure. And actual structure is your nothing but a prototype. That is a full scale structure or full size structure will be termed as your prototype, and its model which will be made to find out or to investigate its few characteristics before its actual construction is termed as your model. छोटी गाड़ी देखी है आप लोगों ने, which is not actual model of that prototype, but that is what the ज्योमेट्रिक मॉडल डमी हम जिसको बोलते हैं ना, वो एक्चुअल वर्किंग उसका सेम नहीं होता है, बट उसको हम बोल सकते हैं दैट इट इज द मॉडल ऑफ द फोन. व्हाटएवर यू आर हैविंग अ सेल फोन, उसका हम मॉडल देखते हैं, दैट इज अ डमी. इट इज नॉट द वर्किंग मॉडल, नॉट द एक्चुअल मॉडल, बट ओनली द डायमेंशनल मॉडल ऑफ दैट प्रोटोटाइप. ठीक है. नाउ व्हाट हैपेंड before going to construction? Now you have to construct or you have to made a dam, a retaining wall. But now these constructions are not very cheap, is it? So it is a costly structure if you have to make a retaining wall. So how that retaining wall will perform in that particular location, in that particular air wind pressure, in that zone, in that velocity, in that pressure. So there are so many variables over where that retaining wall should be constructed. Is it? So before going for the actual construction, there will be formulation or there will be an model by which we can predict the certain amount of forces or certain amount of stresses that will be generated on that retaining wall when it will come into the existence. सो कंस्ट्रक्शन करने के पहले हम लोग उसको चेक करते हैं दैट वेदर इट विल वर्क देयर और नॉट, और विच टाइप ऑफ लैक्यूनास आर देयर, हाउ इट विल परफॉर्म इट्स वर्क ओवर देयर, जिस काम के लिए हम उसको वहां पे प्लेस कर रहे हैं दैट इट विल हैपेंस और नॉट. So these all types of uncertainty will be cleared out by making a model of that particular prototype that we have designed for the actual place. Okay, so these are the advantages. The model tests are economical and convenient, है ना. एक्चुअल हम लोग प्रोटोटाइप जाके वहाँ डायरेक्टली बना देंगे और उसने वैसा काम नहीं किया, so it will be waste of time and waste of money. So before going for the actual project, we have to perform the model testing. Then all the defects in the model, if you will eliminate all the model defects, then definitely the defects in the actual structure will be eliminated. Okay, the final results which you will get out of that model will be useful or be fruitful for the modified design of prototype. Then again, whatever problems you are having with the existing structure, again that can be rectified by the model analysis. If you are having any existing structure and it is dealing with the few types of problem, then you can make the model of that same prototype, and you can perform few types of experiment and analytical study by means of which you can rectify that existing structure also. So now we have said that before constructing an actual prototype, or whenever you have to rectify the problem in prototype, you have to make a मॉडल फॉर द मॉडल टेस्टिंग ओके नाउ मॉडल अब ऐसा तो नहीं है कि दिखने में सेम है नाउ इट इज सिमिलरली लुकिंग सो इट विल बी सेम एज योर प्रोटोटाइप नो सो देयर आर few terms by which we can say that it is the same as your prototype and that similarities will come under your similitude. Now these similarities will be checked by means of three different similarities, that is the geometric similarity, kinematic similarity, and the dynamic similarity. Now, geometric similarity name itself is suggesting these are the similarities which are associated with the dimensions. Okay, you have seen these small toy cars that are nothing but the geometric similar as the prototype. Okay, then second type of similarity is your kinetic similarity. So kinetic name itself is suggesting it is these are the similarities which are related with the flow of the fluid. Okay, so flow में क्या क्या आ जाएगा? Your velocity and the acceleration components. Then third one is your dynamic similarity. Dynamic word itself is used for various types of forces and pressures or stresses. Okay, so all the forces will come under your dynamic similarity. When your model is satisfying all these similarities, then you can say that your model is exactly same model or exactly same as your prototype. Okay, so geometric similarities will deal with the dimensional similarity. Kinematic similarity will deal with your similarity related with the flow, and dynamic similarity will deal with your similarity of forces and pressures. So, okay, so geometric similarity will exist if both of them, that is both the model and prototypes are in shape but in a different scale. Supposed to be if my model is of 10-meter length, then for a prototype, I can select a scale, particular scale. I can have 1:10 scale. That 10-meter of model can be reduced to 10 centimeter of model, or whatever scale you can design. Okay, so their ratios of their lengths, ratios of their widths, or ratios of their depth or height will be termed as your geometric similarity. Okay, Lm by Lp, that is length of model to the length of prototype, will be termed as your Lr ratio, and this Lr is termed as your scale ratio. Okay, for geometric similarity, scale ratio is ratios of it's one of the dimension of model to one of the dimension of prototype, or vice versa. The ratio scale ratio is defined as ratio of one of the dimension of prototype to the one of the dimension of model. Then second similarity is your kinematic similarity. It exists between model and prototype when both are having the identical motions. That is, all the velocity components and acceleration components are similar in scale. Okay, so velocity ratio VR will be velocity ratio of model to the velocity ratio of prototype at any one point. Same for the second point and third point. So it is a ratio of model to prototype or prototype to model velocity. Then third one is your dynamic similarity. Dynamic similarity exists between model and prototype if both the model and prototype are having the identical force quantities and quantities. Okay, so the ratio of their forces will give you the scale ratio in terms of forces. Okay, so Fr will be calculated as force in prototype to the ratio force to the model. Same uh, force or stress or pressure will be calculated as PR will be find out as ratios of prototype pressure to the model pressure. Okay, so when your model and your prototype are satisfying scale quantities or will satisfy all these three similarities, then and then only you can certify or you can say that your model is same as your prototype. Okay. If one of the similarity is not matching, then you cannot say that your model is exactly same as your prototype. Now, once you have made the model, so there must be two types of testing. Now you had made the model with all the similarities. Okay, your dimensions are same, your forces are same, then your motion is same. So your model is exactly same as your prototype. So now you have to test that model. So to test that model, there should be certain laws by which you can test that model. So that model uh, test will come under your model testing. Okay. When you cannot perform experiment on the full size structure which are proposed to erect, then it is necessary to construct these small types of replica. And to test this replica, we have different types of laws, and those laws are termed as a model laws. Now, each law is associated with the each dimensionless quantity. Okay. Prior to that, we have seen that there are five types of dimensionless quantity, that is Reynolds number, Raoult's number, Euler's number, Weber's number, and Mach number. So on the basis of all those five dimensionless quantity, there are five model laws, and those laws are termed as your Reynolds model law, Raoult's model law, Euler's model law, Weber's model law, Mach's model law. Again, these are the ratios of corresponding forces acting on the corresponding point in model and prototype. So, law should satisfy the which similitude? Here we will check the force related similitude. Okay, that is the dynamic similitude, because Reynolds, Raoult's, Euler's, Webb's, Max, all these numbers will gives out to be the quantity in terms of forces only. So in model law, you are actually checking out the forces which are acting on the prototype and model, that these two forces are in ratios by which you have constructed or you have modeled the model. Okay, so your first dimensionless quantity is, your first model law is Reynolds model law. Okay, so Reynolds model law is law in which models are based on Reynolds number, that is a Reynolds dimensionless number. Okay, so now how you will find out or how you will calculate the, you will apply the model law, the Reynolds number of model or Reynolds number of prototype must be equal. Okay, so Reynolds number for prototype can be rho vd or rho vl by mu. So it must be equals to the rho vd or rho vl for the model itself. These two quantities must be equal. Same for the Proud's model law. The model are based on the Proud's number, which are related with the dynamic similarity between model and prototype, and both of them should be equal. Okay. Here, your Proud's number, that is Proud's dimensionless quantity for model, must be equal to Proud's dimensionless quantity for the prototype. The Proud's number can be calculated by P divided by square root of GD. Then there is Euler's model law. Euler's model law is based on the Euler's number. So for both the prototype and model, Euler's number should be equal. Euler's number is calculated as ratio of velocity to the square root of pressure by density. So this quantity should be same for both the model and prototype. Okay. Your next model law is your Weber's law. So again here your Weber's model law, which is based on your Weber's number, and the Weber's number should be same for both the model and prototype, and same for the Mach's number. Okay. See, by performing these tests, these model testing, we are confirming that whatever model you have made is exactly same as the prototype, because dimensions can be made easily. A 10 meter of model, 10 meter of prototype you have to construct, so you can make a dimensional quantity in a ratio. Okay, so dimensional similarity can be matched easily, but the forces which are acting on that particular prototype cannot be matched easily. That is why it is essential to perform these model laws. Once you are satisfying with these laws, then you can confirm that your model is actually same as a prototype which to be built. Okay, now there are two types of models. These are distorted models and undistorted models. Okay, now sometimes what happened, you cannot exactly match the dimensions of all the existing prototypes. Supposed to be consider an open channel or a river. Okay, now in case of river, what will happen? The vertical dimension is actually very less as compared to your horizontal direction. Is it? The vertical y direction dimension is supposed to be a depth of river is um, 1 meter for an example, but its width will be thousands of kilometers. Is it? So in this case, it is actually impossible to construct an exact model. So for this case, you will construct a model which will be not similar in a y direction but similar in a x direction. Okay, so this type of model is termed as a distorted model. And what is an undistorted model? Undistorted model is where geometry is similar to its prototype. A scale ratio for corresponding linear dimension of the model and prototype are same. Okay, so what is advantage of undistorted model then? The basic condition of preferred geometric similarity is satisfied. It means we are exactly matching all the dimensions, its width, its height, its depth, all the dimensions are same, then it will be considered as your undistorted model. Okay, what are the exact results you will obtain from the model you can directly apply to the prototype. But in distorted model, when your horizontal and vertical dimensions are not up to the scale. If supposed to be you are having a 1 kilometer length of a river and its depth is only 100 meter. So in this case, it is actually inappropriate. You will have a model which will be a longer and having a very least depth. Is it? So in that case, you have to modify your or you have to use two different types of scale in vertical and horizontal dimension modelings. Is it? So this will be termed as your distorted models. Now advantages can be accurate and precise measurement are made possible due to the increased vertical dimension. Model size can be reduced, but again disadvantage is there. Depth and heights are not same. It is distorted. Then you cannot apply all the results directly to the prototype because your dimensions are not as similar as the prototype. Okay, then your next topic is, so basically in dimensionless quantity, you have seen the various dimensionless quantity. Then there are laws which you have to satisfy for making your prototype exactly same as model. Then there are few types of similarities which you have to check before constructing a model analysis or before going for the model testing. Okay, now we will move to our next topic, that is your kinematics of flow. Kinematics of flow. Kinetics is nothing but kinetics will deal with the forces, how the forces are acting and the behavior of forces. But kinematics is deals with the forces or the pressure forces when you will not consider it, when you will not consider the effect of pressure forces on a particular object or a moving body. Okay, so the kinetics of flow, on the basis of kinetics of flow, there are various types of classifications are given. So first classification is your steady and unsteady flow. You will say your flow is steady when you will not consider the when your flowing parameters like velocity, pressure, and density will not change with the time. Okay. See, all the classifications are based on the parameters of velocity, pressure, and density. Okay. If these are vary with the time, then this flow will be considered as an unsteady flow. And if it is not changing with time, then it will be considered as a steady flow. Same for the uniform flow, but here your varying parameter is your space and time. When your velocity, density, and pressure, these terms will change with the time, change with the space, then your flow will be non-uniform flow. Okay, if supposed to be your gradient will change of the channel In figure you can see. So this will be considered as a non-uniform flow because it is changing with the space. Space it means a three-dimensional quantity. When these quantities will not change with space, then this will come under as your uniform flow. Then there is a laminar flow and turbulent flow. Laminar flow is nothing but a streamlined flow. When your water follows a streamlined flow, and if your Reynolds number is lesser than 2000, then it will be laminar flow. And if your fluid moves in a haphazard manner or a zigzag manner, then it will be a mixed type of flow or a turbulent flow, and it is having a Reynolds number of greater than 4000. Then next type of classification is your compressible flow and incompressible flow. Compression and incompression. Compression of liquid or air. These terms are associated with the density. Okay. So if the density of fluid will change, then it will come under as your compressible flow. And if the density will not change, then this will be considered as your incompressible flow. Then there is a rotational flow and a rotational flow, a fluid where a fluid particle while flowing along a streamline rotates along its own axis and will be considered as a rotational flow. And when the fluid particle do not rotate about its axis, then it will be considered as a rotational flow. Then one dimensional, two dimensional and three dimensional flow. One-dimensional flow, when you will consider the velocity component in one direction only, that is supposed to be if you are considering a velocity component in x direction, so that will be your u component. Okay, if you are considering your velocity component for two direction, that is u and v, x and y, so it will be considered as your two-dimensional flow. And when you are considering this as in your three-dimensional quantity, that is u, v, w, x, y, and z, all three planes, then this quantity will be termed as a three-dimensional flow. Okay, so all the classifications are different classification to classify your flow. You can go with the any one of the classification for your further study. All the classifications are based on the one parameter has been kept constant and other has been kept as a variable. Okay, your last topic for today's discussion is based on the hydraulic machineries. Okay, so what is hydraulic machine? Everyone has might have heard about the hydraulic machine at least. Hydraulic machines are the machines which will convert your hydraulic energy to some another part of energy. Okay, it will be either mechanical energy or electrical energy or pressure energy or kinetic energy, potential energy, or all parts to be together. Okay, so machineries are classified into two main types. These are your turbines and hydraulic pumps. Okay, so basic classification of hydraulic machine is done on two categories, that is your hydraulic turbines or turbines and your hydraulic pumps. Okay, so what is turbines? What are turbines? Turbines are nothing but which will convert your hydraulic energy to mechanical energy and mechanical energy to electrical energy. And what are pumps? Pumps will convert your electrical energy to mechanical energy and mechanical energy to again a hydraulic energy. Okay, so we will go with the turbines. So there are so many types of different turbines. Our classification is given on the basis of different parameters. The plus classification is given at the on the basis of energy at inlet, that is impulse type and reaction type. Then according to the flow rate or the flow type, it is again classified into four types. Then according to the heads, high head, medium head, and low head, and according to the specific speed, they are classified as low, medium, and high specific speed turbines. Okay, amongst these, a Pelton wheel turbine is very important as concerned with your university examination or according to your competitive examination. So we will just quickly see the working principle and the components parts of Pelton turbine. Okay. So Pelton wind turbine is used or it generates the electricity converted by the hydraulic energy. Okay. And it is used for the water available at high heads. If your Pelton wheel turbine is located or associated at the high heads, then it will be more beneficial than at a lower altitude. Then it is a tangential flow type and impulse type turbine. Okay, this question may be asked in your exam that which type of turbine it is. It is a tangential flow type and impulse turbine having a high head, and it is used to generate electricity in the hydroelectric power plant. This turbine was discovered by American engineer L.A. Pelton. Okay, so what are the various part or various components of the Pelton wheel turbine? It is having a nozzle or a sphere, then there is a penstock, there is a casing, there is a bucket, and there is a runner. Okay, so a nozzle is used to increase the kinetic energy of water that is going to strike the bucket or vanes attached to the runner. See here, we are having a nozzle. Okay, out of that nozzle, a water will strike out, and that will strike to the bucket or the runner. Once the kinetic energy of the running water will transfer to the bucket will start to move in a clockwise direction. Then there is a runner or bucket. Runner is rotating part of the turbine. ओके दिख रहा है आप लोगों को जो बकेट के अंदर का पार्ट है जो ड्रम टाइप का दिख रहा है जहाँ पे एरो है दैट विल बी कंसीडर्ड एज योर रनर ओके सो वंस the kinetic energy of the water flowing through will transfer to the bucket, this runner will going to rotate about its axis. It is a circular disc. Okay, the bucket are made up of two hemispherical balls. Okay, outside and inside there will be two hemispherical balls, and these buckets are deflected at 160 to 170 degree inclination. They are not horizontal or 180-degree incline. They are 160 to 170-degree incline. And they are made up of either cast iron, cast steel, bronze, stainless steel. Then there is a casing. Casing is nothing but the outer body of this Pelton turbine. Okay, and then there is a braking jet. Here upside you can see there is a braking jet. What this braking jet will do, when the jet of the water is completely closed by pushing the sphere in the forward direction, then the amount of water striking the runner becomes zero. Okay, if you have to obstruct or if you have to stop this machine, then there will be use of braking jet. Then we will see the working. Now see, the water stored at a high head is made up of flow through the penstock. Okay, penstock is nothing but a larger diameter pipe and reaches the nozzle of the Pelton turbine. The nozzle increases the kinetic energy of water. Is it? पेनस्टॉक से पानी आ रहा है ठीक है उसका डायमीटर ज्यादा है जैसे ही वो नोजल पे आएगा नोजल will reduce its nozzle is having a reduced diameter because of this reduced diameter the pressure and the kinetic energy the pressure and the velocity of the water will increase. The jet of the water from the nozzle strikes the bucket and this made the runner to rotate at high speed. The generator is attached to the shaft. Okay, below to that there will be a shaft attachment and runner which converts the mechanical energy into the running electrical energy. Okay, so what is the application of this Pelton wheel turbine? सभी को पता है कहाँ यूज होता है सबसे पहला एप्लीकेशन है इसका हाइड्रो इलेक्ट्रिक पावर प्लांट्स में ओके विच आर अवेलेबल एट हाई हेड दैट इज 150 to 2000 meter or even more than that. Again it is used to drive the generator attached to the mechanical energy of the turbine into the electrical energy. Okay, so these are the arrangements of buckets. We have seen that. Then there is one more type of turbine that is the Francis turbine. It is the inward flow reaction type of turbine. Okay, Francis turbine and Pelton wheel turbine runs on the same principle, but they are having the different arrangement of the casings. Okay, one example I have given over here. It is based on your model and prototype. We are running short of time on it. ठीक है इसको लास्ट में देखते हैं हम लोग ठीक है एग्जाम्पल को ओके, अगेन these are classified on the basis of head, specific speed. ये हम लोगों ने देख लिया. Now just we will quickly go through the velocity triangle given for the Pelton wheel turbine. This is everything we have seen that penstock क्या होता है, nozzle क्या होता है, all definitions are given here. Okay, yes. Now we will see the velocity triangle of Pelton wheel turbine. Now see, this is how the velocity triangle of Pelton wheel turbine looks like. Okay, so there are so many notations like V1, V2 are the velocity at jet inlet and the outlet. See here, this V1 and V2 are the velocity of jet inlet and outlet. Then VR2, VR1, VR2 are the relative velocity with respect to bucket. Then U1, U2 is the bucket velocity. Then UT1, T2 are the velocity component in direction of motion. Then alpha is the angle between the direction of jet and the direction of motion of bucket. Theta is the angle between the velocity and direction of motion of bucket. That is the velocity of inlet and outlet of the jet. Then phi is the angle between the velocity of jet and the direction of motion of bucket. Okay, so we'll see one example based on this velocity triangle. You have to memorize all these formulas. These are given over here. You can see if your problem is given on the basis of Pelton wheel turbine, then once you will know the formulas, you can directly solve out the problems. Okay, just see. Just read this problem. A Pelton wheel is to be designed with the following specification. Shaft power is given, head is given, speed is given, efficiency is given. Jet diameter in 1/10 of wheel diameter. Determine wheel diameter, number of jet required, diameter of jet. Okay. Coefficient of velocity and coefficient of velocity for two different components is given. Okay. So your velocity of jet can be calculated as CV square root of 2gh. Okay, CV is given 0.98 into 2gh, that is head is given 400 meter. Okay, then your u will be same as u1 and u2 for this case, and this will be calculated as cu divided square root of into square root of 2gh. Then you have to find out the that you have to find out the velocity. Okay, you have to find out the number of jet. So before going to number of jet, you must know about the D. So D will be calculated as U into 65 pi into N. So you will get your U as 0.951 divided by 10. That is your D. Then discharge of one jet can be calculated as pi by 4 D square. Discharge is nothing but area into velocity. So V1 is your 86 0.81 and diameter you had calculated. So by this you will get your discharge. Okay, velocity you had calculated as 86.81, that is V1 in step number 1. Then you have to find out the overall efficiency. Overall efficiency is nothing but your ratio of shaft power to water power. Shaft power is given and water power हम लोग कैसे निकालते हैं, rho QH divided by 1000. ठीक है, that is the WQH divided by 1000. So discharge मिल जाएगा आप लोगों को 3.5 meter cube per second. Then number of jets is nothing but the total discharge to the discharge of single jet. So how many jets are required? You will require 6 number of jets. Okay. Then there is one more concept, and it is actually very much important. That is this specific speed of the turbine. A specific speed of the turbine is given as n into square root of p divided by h to the power 5 by 4. And same for the specific speed of pump is given by n square root of q divided by h to the power 3 by 4. These two formulas are very important in concern with your examination. A direct values are given to you to calculate the specific speed of the hydraulic turbine. Then there are pumps. Okay, so again pumps are the machinery or the equipments which will convert your electrical energy to mechanical energy and mechanical energy to hydraulic energy. So pumps are basically a reciprocal of your turbine. Okay. So hydraulic pump is a hydraulic machine which will convert your mechanical energy to hydraulic energy and by the use of centrifugal force acting on the fluid. So there are two types of basic pumps are there. These are your centrifugal pump and the reciprocating pump. Okay, so we will see one by one. So centrifugal pump is used in agriculture, municipal corporation, industrial, then again power plant generation, petroleum. Okay, when a certain mass of a liquid, a certain fluid mass is rotated by an external source, then it is thrown away from the centrifugal axis. And the centrifugal का नाम ही क्या है? It should be away from the center. Is the centrifugal force. So here also it works on the same principle. The water or the liquid will be thrown away from the centrifugal axis of the rotation and head is impressed, which will enable it to rise a higher level. Okay, so there are this is the this is how your centrifugal pump looks like. It has an impeller. Impeller is a wheel or rotor which will provide with a series of backward curved blades and vanes. The inner portion is nothing but your impeller portion. Okay. There are basically again there is a type in impeller. There are three types of impeller. Open impellers are there and semi-enclosed are there. The enclosed type of impellers are there. Okay, then there is a casing. Again, the outer part of this will be termed as your casing. Then there is a delivery pipe. The upper pipe, this pipe is your delivery pipe, and this pipe is your suction pipe. Okay, by the means of delivery pipe, you will get your water at the outlet, and this suction pipe is used for the entry of the water. Okay, now we will go with the working of the centrifugal pump. Now, very first in the operation of centrifugal pump is the priming. Priming is nothing but adding a water to remove the air pressure from the pipe. घर में हमारा जो पाइप होता है मोटर में कभी कभी मोटर पानी नहीं देती तो हम लोग क्या करते हैं you will add a water in that green pipe, so that is nothing but your priming. यहाँ पे भी हम लोग जब पंप ऑपरेट करते हैं तो एक फुटबॉल होता है, फुटबॉल को खोल के हमको वहाँ पे पानी डालना पड़ता है. That is nothing but your priming. In pumps, it is very much essential to check whether the water level in that football is at up to the mark or not. If it is not, then you have to add water into it to do the priming. So what priming basically does, in this operation, suction pipe casing of the pump and the position fluid with the liquid which is to be pumped, so all the air from the position of pump is driven out. Okay. Now once it is primed, delivery valve is kept closed. Okay. जो ऊपर का valve है उसको close कर देंगे and electric motor gets started. The delivery valve is kept closed in order to reduce the valve is open. The liquid is made to flow in an outward radial direction, thereby veins of impeller at the outer circumference with high velocity at water. Now, when a water from the suction pipe from the bottom of the channel will come onto the impeller on the drum, what will happen? It will rotate, and after rotating, then when it will start to rotate, your valve is closed at the delivery pipe. Once it will start to get rotate, you will open the delivery pipe and your water will get reach to your outlet point, that is your delivery pipe, and it will get up to the altitude or your desired height. So this will cause your liquid to some to rush through the suction pipe to the center, or it may called as the eye of an impeller, thereby replacing long discharge from center circumference to the impeller. Okay. Then there are few types of applications of this centrifugal pump. It is used in oil and energy, industrial and fire protection industries, waste management industries, pharmaceutical industries, and various Industries like manufacturing, chemical, pharmaceutical, food production, aerospace, for the use of refrigerant or for the use of water at the high altitude. Okay, this is the velocity triangle of centrifugal pump. These are all the notations which were used in this velocity triangle, and you have these are few formulas by which you can find out the various unknown quantities or unknown components of centrifugal pump. Okay, so here discharge is again given by rho g QH by 1000. Okay, rho g H. Now here H is head. So for pump, you have to take summation of both the heads. That is the summation of suction head plus summation of delivery head. Okay, so your H quantity over here will be your HS plus HD. That is the suction head plus delivery head. Then specific speed for pump will be calculated as n root q divided by h to the power 3 by 4, and wherein for the turbine it is n root p h to the power 5 by 4. Okay, don't mess up with these two formula. The second type of pumps are the reciprocating pump. Again, reciprocating pump will convert your mechanical energy or electrical energy to mechanical energy or mechanical energy to hydraulic energy. Okay, it is done by the in centrifugal pump, it was done by the impeller. Okay, the center part, that is the eye part of the casing. But here it is done by the reciprocating action of the pump. Reciprocating action is nothing but an action associated with the crank, a to and fro motion like an injection. You have seen the injection? It is same as the phenomena that will be used in an injection. There will be crank which will move into and fro position, which will create a suction or vacuum into that space, and that will lift your water from backward to forward condition or from lower to upward condition. Okay, so a reciprocating pump is a hydraulic machine which will convert your mechanical energy to hydraulic energy. Okay, just observe this figure. Here, what will happen? Certain quantity of volume will be collected or enclosed and is discharged using the pressure to the required application. Again, the main parts here you can see suction pipe, suction valve, delivery pipe, delivery valve. There is a cylinder. There is a in between a piston. There is a crank. There is a strainer, and there is a air vessel. Okay. So suction pipe is used to suck the water from the water reservoir. Then suction valve, a valve will present at the suction level. The suction valve is a one-way valve or non-return valve. Once your water has been entered into the piston, then this valve will get closed automatically. Okay. Suction valve, out of this suction valve and delivery valve, only one valve will be operated at a time. If your suction valve is working, then your delivery valve should get closed. If your delivery valve is open, then your suction valve should be closed. Okay. So both are the non-return valves. Only one-way valves are there. In suction valve, only water can go outside, and out of delivery valve, again water will go the outside. Then there is a cylinder. It is a hollow cylinder inside a casing. Okay, then there is a piston, is a solid type cylinder which will move backward and forward inside the hollow cylinder to perform the suction and delivery of liquid. Then there is a crank. Crank is nothing but a solid circular disc होती है which is connected to a power source or a motor. Okay, crank move होगा आगे पीछे तो पानी का movement होगा. Then how it works? In this pump consists of piston that moves forward and backward in a closed fitting cylinder. The movement of the piston is obtained by connecting the piston rod to crank. By means of connecting rod, the crank is rotated by means of an electric motor. The suction and delivery pipes with a suction valve and a delivery valves are connected to a cylinder. Okay, the suction and delivery valves are the non-return valves which will allow the water to flow in one direction only. So suction valve will allow water from the suction pipe to the cylinder, wherein the delivery valve will allows your water from the cylinder to the delivery valve. When this crank start moving by the help of cylinder, piston moves in the cylinder. Okay. Now see when the crank is at A position, just refer this figure, the piston in the extreme left position in the cylinder. As the crank is moving from A to C position, that is from 0 to 180 degree, the piston is moving towards the right of the cylinder. Is it? The movement of piston toward the right creates a partial vacuum in the cylinder, but on the surface of liquid in the some atmospheric pressure is acting. At the sump level there is atmospheric pressure, but at the outlet there is a pressure which is greater than the sump level. Is it? Which is more than the pressure inside the cylinder. Thus a liquid is forced into the suction pipe from the sump, and this liquid opens the suction valve and enters into the cylinder. The pressure outside the suction pipe is greater as in the suction pipe. So that is why when water will come to the sump level, it will open and it will enter to the cylinder. Okay, then when a crank is rotating from C to A position, the piston from the extreme right position will turns out to the extreme left position. The movement of piston toward the left increases the pressure of the liquid inside the cylinder more than the atmospheric pressure. Again here, the suction valve closes and delivery valve open. The liquid is forced into the delivery valve and is raised to the required height. Okay, so the whole phenomena is basically because of there is such an arrangement, the pressure drops or the pressure differences are there. There are two types of reciprocating pump, single acting and double acting. Okay, in single acting and double acting reciprocating pump, there is few difference in the formulas. Okay, just go through it. Okay, single acting reciprocating pump itself, it is saying, name itself is suggesting single, that means there is only one suction and delivery valve. Okay, the fluid will get into the suction by only one pipe and in only one direction. In double acting, there will be two suction and two delivery valves. Okay, when the piston in the cylinder is in between, then one suction and a delivery pipe is on one side, and one suction and delivery pipe will be on the another side. Means on both the sides there will be one suction and one delivery pipe. Then application है इस पंप का ऑयल ड्रिलिंग मशीन में, then light oil pumping, then feeding small boilers, then it has a advantage of high pressure at the outlet. Then in centrifugal pump you require a priming. Here there is no need of priming. Then it provides a high suction lift. Then it is used for the, it can be used in air prone areas also. It has the advantages such as it requires high maintenance cost. Then the flow rate inside the inside the pump is quite lesser as compared with the reciprocating pump. In as compared with the centrifugal pump. In centrifugal pump, the process is continuous, but here your process is intermittent. It is quite heavier than your centrifugal pump, and high initial cost is required. Maintenance cost is quite lesser as compared with the centrifugal pump, but the initial cost is higher as compared to the centrifugal pump. Okay, so a theoretical discharge for the single acting reciprocating pump is calculated as ALN by 60. Okay, and for double acting reciprocating pump, A is nothing but your cross sectional area of piston, L is length of the crank, N is your number of rotation divided by 60. For double acting, it is A twice ALN by 60. Okay, then pressure will be calculated as area into discharge into rho g. Okay, so area, sorry, discharge into rho g into head. Okay, rho g QH. So rho g into Q will be calculated as ALN by 60 and H is nothing but your summation of suction head and delivery head. So your total correction in discharge that will be termed as your slip condition can be calculated as Q theoretical minus Q actual. Q theoretical can be calculated by means of these formulas and Q actual will be find out by means of your practical performance. So one problem is there. We'll just go through it. Okay. A single acting reciprocating pump running at 100 rpm delivers a 0.1 meter cube second of water. The diameter of piston is 500 mm and stroke length is 400 mm. Determine theoretical discharge, percentage slip and coefficient of discharge. Okay. So first one is to you have to find out the theoretical discharge. Theoretical discharge is nothing but ALN by 60. So area is your pi by 4 d square. Diameter is given as 500 mm, that is 0.5 meter into n is given your 100. Speed is given of the pump, that is 100 rpm, and length is given as 400 mm, that is 0.4 divided by 60. You will get your discharge as theoretical discharge as 0.13 meter cube per second. Okay, and Q actual it is directly given to us as 0.1 meter cube per second. So your slip percentage slip can be calculated as difference between theoretical and actual discharge to the theoretical discharge ratio. So you are getting a percentage slip of 23%. It means 23%, it means you are having a huge loss in the pump. So there is requirement of maintenance of the pump because more than 20% of the losses are considered to be the higher amount of losses. Then there is you have to find out coefficient of discharge. Coefficient of discharge is Q actual by Q theoretical. Q actual है Q actual दिया है आप लोगों को 0.1 and Q theoretical is 0.13. So your coefficient of discharge is 0.769. If you are having higher amount of losses, then definitely your coefficient of discharge will be of lower side. Okay, coefficient of discharge, if it is you are getting a value coefficient of discharge greater than 0.8 or 0.9, then it means your pump or your machinery is working well, behaving well. Okay, एक न्यूमेरिकल था वो रह गया था, वो देख लेते हैं फटाफट, then we will stop here. Okay, this numerical is actually based on the dimensionless quantity or the similitude model analysis पे based है. ठीक है, read out this problem. A pipe of diameter 1.5 meter is required to transport an oil of specific gravity and viscosity. Okay, then rate दिया है और दिया है 15 सेंटीमीटर डायमीटर पाइप पे टेस्ट परफॉर्म हुई है. Find the velocity and rate of flow in model. You have to find out the Vm and Qm and viscosity is given. Okay, or write down all the given quantities. Then फर्स्ट लेक्चर में हम लोगों ने देखा था स्पेसिफिक ग्रेविटी वाज गिवन, so you can find out the density. So here density of oil can be calculated as specific gravity into 1000, that is density of water. So it will be a 900 kg per meter cube. Then diameter of model is 15 centimeter, which is given to you. So here see, you are given with the parameters like discharge, density and diameter. So you have to find out all the given quantities which are given to you will fulfill which law or dynamic similarity. Okay, so here you can apply the Reynolds number model law or the Reynolds dimensional analysis. So Reynolds law क्या बोलता है, rho VD by mu must be equal to rho VD by mu for the model and prototype. ठीक है, अब यहाँ पे हम लोग बाकी जो क्वांटिटी कांस्टेंट है वो चली जाएगी, तो वेलोसिटी एंड डेंसिटी, diameter and dynamic viscosity, these all four quantities are given to you. So just put all the values which are given to you, you will get a velocity ratio that is 3. Okay, then velocity of prototype will be calculated as continuity equation Q by A, Q is equals to area into velocity, area into velocity. ठीक है, तो velocity क्या हो जाएगा Q by A, तो velocity of prototype will be 1.697. Okay, so you have the velocity ratio that is Vm by Vp is 3 and you have the velocity of prototype, that is 1.697. So Vm will be 3 into Vp. So you will get your velocity of model that is 5.091 meter per second. Again, और क्या पूछा है हम लोगों को? रेट पूछा है. You have to find out the rate of flow in model. So again, rate of flow will be calculated by using the discharge formula, that is Q is equals to area into velocity. Area will be pi by 4 d square into v. Okay, you have to find out the discharge for model. So model का dimension है 15 सेंटीमीटर और उसके उसकी velocity आप लोगों ने भी निकाली है, that is 5.09. So you will get rate of flow of model as 89.9 meter per second or 0.0899 meter per second. Okay, so here we will finish with the first part of your hydraulics. Today we have covered about the forces on immersed body. Then we have seen the measurement of flow with the various devices like venturimeter, orifice meter. Then there is a flow meter and a pitot, and one horizontal float pipe is also there. Then we have seen the similitude, dimensionless quantity, model testing, and the various dynamic laws. Then there are hydraulic machineries. In hydraulic machineries, basically there are two types of machineries: turbines and pumps. Turbines will convert your hydraulic energy to mechanical energy, and pumps will convert your mechanical energy to hydraulic energy. In turbines, there are transient turbine and Pelton wheel turbine. These are two main types of turbine which you may be asked in your university examination or in competitive exams also. And for pumps, you are having a centrifugal pump and reciprocating pump. Okay, so thank you. So we will finish with our discussion. Thank you.